then we will return to this. So we'll leave it on just for now while it is charging. The idea of a photo flash is that you charge up a capacitor and that you discharge it over a light source. So the idea being that you have a capacitor, let me erase some of this, and that we charge the capacitor up, put a certain amount of energy in there, and then we dump all that energy in a bulb. So here is the capacitor. We're going to charge it up. We have a switch here, and here is a light bulb. And when we throw the switch, then all the energy will be going to the light bulb. If this is positively charged and this is negatively charged, a current will start to flow, and you will see a flash of light. I have here a capacitance of 1,000 microfarads. So C equals 1,000 microfarads. I'm going to put a potential difference over that capacitor of 100 volts, which then gives me an energy of 1/2 CV squared, which is 5 joules. In fact, this is not just one capacitor, but these are 12 capacitors, which I hooked up in such a way that the 12 capacitors of 80 microfarad each are a combined capacitor of 1,000 microfarads. And so, I'm going to charge it up, and then I'm going to discharge the capacitor through the light, and then you will be able to see some light, perhaps, depending upon how much energy we dump through there. So concentrate now on this light bulb. The 100 volts, you should see here. Do you see it? So it's set at 100 volts now. And I'm now going to charge it. And the moment that I charge, you will see the voltage over the capacitor. And so it takes a while for it to charge up. So it goes very down to 0 and then slowly comes back to 100. It may take 5 or 10 seconds. So if you're ready, then there we go. Took only 5 or 6 seconds. And so now we have 100 volts, so we have 5 joules stored in there, and I'm going to discharge that now over this light bulb. If you're ready, 3, 2, 1, 0. A little bit of light. I can tell that you're disappointed. It's not very exciting. It's not really my style, is it? Well, what we can do, we can increase the voltage a little bit. We could go to 250 volts, in which case, since it goes with V squared, we would have 6 times more energy, so then we have 30 joules. So let's see whether that's a little bit more exciting. So now I have to jack up the voltage to 250 volts. Now you see the power supply again. 250 volts. We're getting there. We don't have to, oh boy, am I lucky, on the button. So 250 volts. And now I can charge up again. It will take a little longer. So you'll see the voltage over the capacitor. 140, 170, 200, 250, there we are. And now we can see whether we get a little bit more light. So you go from 5 joules now to 30 joules. 3, 2, 1, 0. Aha, now we're getting somewhere. Now you really see how a photo flash works. Now, we all, of course, have destructive instincts. And so you wonder, right? You're thinking the same thing that I do. Shall we try 340 volts and see whether the bulb maybe explodes? I don't know how high this voltage supply can go. Let's see. Let's go all the way. 337 volts. Okay. So that would mean that we have 50 joules roughly. It goes as the voltage square. Well, let's charge again. So we're charging now. 200, 280, 300. There we go, 337 volts. Now let's see. Ah, we did it! It broke! I have a photo flash, and I have the photo flash here. And this photo flash has a capacitor of about 5,000 microfarads, real biggie. And we can charge that up to a potential difference of 100 volts. Even though the batteries in there are only 6 volts, there is a circuit in there, we'll learn about that later, which converts the 6 volts to 100 volts. And so we can charge up this capacitor to 100 volts. And that means that the 1/2 CV squared, the energy stored then in that capacitor, will be 25 joules. And I can dump that energy over the light bulb, and then we see a bright flash of light, because this discharge can occur in something like only a millisecond. So you get a tremendous amount of light only for that millisecond. And I want to demonstrate that to you. And the only way I can demonstrate that to you is by aiming this flashlight at you. I don't want to damage your eyes, so I warn you in advance. So I am charging up now my capacitor. It will take a while, and I'm going to take your picture. I might as well. But it's going to be very dark in the back there, and so I've asked Marcos and Bill to also have some flashlights, which go off at the same time that my flashlight goes off. Now you may say, well, how can you do that? Because if this flash only lasts a millisecond, how can you synchronize that? Well, the way that's done is that those flashlights are waiting for my light signal to reach them. And that goes with the speed of light. It takes way less than a millisecond to get there. And they go at the same time that they receive my light flash. And so we call them flash assists. And so let's see whether we can do this. I have a green light here. That means I can take my picture. And yeah, you can. Oh, you don't have to comb your hair, but you're looking good. Okay, let me focus, because that's important. So make sure you see the flash. You ready for this? Did you see the flash? Did it flash? Oh, it did. Oh, you can say yes. So did the light assist also flash? Okay, but you haven't seen that yet, right? Because you were looking at them. You really should have looked at me. So why don't we take a picture, Marcos, Bill, aim the flash assist at the students here, and then we'll try it again. You ready? Okay. Oh boy. Why don't you say cheese for a change? Okay, look at me. Oh boy, you're looking great. You really, oh, right, you're out of focus. There's one person sleeping there. Oh, we'll let him sleep. That's okay. Did that work? Did you see the flash? You did, eh? 25